Hi, today I will talk about how to start application development with Zephyr OS on Raspberry Pi Pico. Zephyr OS is open source, real-time OS for embedded devices and it is part of Linux Foundation. Some of the key features are small footprint, scalable, multi-architecture, and native POSIX support. If you are familiar with the Linux kernel but need a small one or need real-time OS for your IoT projects, I highly recommend Zephyr OS. I will walk through the steps you need to set up the development environment, how to build and run Blinky sample. Development environment setup. The steps are straightforward, just install all the necessary components step by step. First, select and update your OS. Install dependencies. I will be using Mac OS. Install Homebrew. I already have Homebrew, so I will pass this step. Use Brew to install the required dependencies. Since I already have Python 3, 3.9 and gperf, I removed from the list. Get Zephyr and install Python dependencies. I will install globally since I don't have another environment. Please use install within virtual environment if you need. Install West. Get the Zephyr source code. Export a Zephyr CMake package. Install Zephyr's Python dependencies. Install a toolchain. Download and verify the Zephyr SDK. Extract the Zephyr SDK bundle at one of the following locations. Run the Zephyr SDK bundle setup script. Build the Blinky sample. To build the Blinky sample, we need the Raspberry Pi Pico board name definition. Here it is. Let's flash the binary. I will use the UF2 method for flashing. Put your Pico into bootloader mode. Change directory to build folder. And check the UF2 file. Then copy the UF2 file to your Pico storage. And it is working. Let's check the source code of the Blinky sample. This is the variable of the LED we are toggling. It is defined here using LED0 node. An LED0 node is defined here using device tree node of LED0. Let's check the device tree file for the Pico board. You will find hardware physical layout definitions of the board. When we need to add external hardware to our Pico board, we will use overlay file, so do not change device tree files. I will explain that later. This is LED0 definition and it is GPIO port. Let's check the LED's GPIO port from Pico's pinout document. It matches with the device tree file. In the next episode, I will talk about creating a new project and its layout. I hope you find this video interesting. Please let me know what you think in comments. Please consider like, share, subscribe and click the bell button. Thanks for watching.